Boom! Yeah, Hume here again, we're going. So we're gonna continue in this series where we're talking about multiplication and division of fractions. In this video, I want to draw a clear contrast between multiplying a fraction by k, dividing a fraction by k, and a particular manipulation where the actual value of the fraction doesn't change at all. So there we go. If we multiply the numerator of a fraction by k, right? So if you have n over d and you multiply the numerator alone by k, what you are in fact doing is multiplying the whole fraction by k. That's this guy here in the first row. If you multiply the denominator of the fraction by k, you multiply the denominator alone by k, what you are in fact doing is dividing the whole fraction by k. That is this line in the middle here. And if you multiply the numerator and the denominator by the same k, what you are in fact doing is nothing. You're not changing the value of the fraction. You might change the appearance of the fraction, but the value doesn't change. So in other words, the form might be altered, but the substance remains the same. So take a look at it, right? You have it on video, so you have the opportunity to pause and write it down, take a snapshot, whatever it is. But we're going to do some examples now, just to illustrate in concrete, easily understandable terms this abstract thing here. You know, when people say a lot of letters, problems. So we're going to throw in some numbers now. All right? So there we go. And what I will do, I will illustrate it. I will illustrate it using examples that you can see and some that might be so obvious. So there we go. If I have, let us say, a fraction, let me say the fraction is let me say the fraction is 50 over 50 over 5, right? 50 over 5. 50 over 5. That's no. I need to choose better numbers than this. Let us say I have the fraction 48 over 12. Much better. Alright? 48 over 12. Now, of course, you can see that this could reduce. And I'm doing it like this deliberately so you can understand and see what I'm saying. We know that 40 divided by 12 is 4. Right? 40 divided by 12 is 4. We know that. But if I decided to multiply the numerator of this fraction by 2, so in other words, I move from 48 over 12 and I say 48 by 2 over 12. Right? That is the same thing as 48 by 2 is 96 over 12. 96 divided by 12 we know is equal to 8. You see? So 48 divided by 12 we know is 4. We know 48 divided by 12 is 4. 4 timetables. Right? We multiply the numerator alone by 2. And then when you break it down, you discover that this is actually equal to 8. So what we have in fact done is by multiplying the numerator alone by 2, we multiply the whole fraction by 2, the whole thing by 2. So in other words, if we know 4 by 2 is 8, what we wasn't sure about is that 48 over 12, which is the same 4, if you just multiply the 48 alone by 2, what you're in fact doing is multiplying the whole thing by 2. Let me flip the script. So we draw a line here. And we say, we divide. No, sorry. Let me say that over. Let us say we multiply the denominator alone by 2. So we have 48 over 12 by 2. Which is the same thing as 48 over 24. And we know that 48 over 24 is 2. Which is half of 4. So in other words, 4 divided by 2 is 2. Right? So by multiplying the denominator alone by 2, what we are in fact doing is dividing the whole entity by 2. And you see it here in the numbers. If you wasn't sure of what I was saying in the previous video, you look at the numbers, you treat the 48 over 12 as a fraction. In this case, you multiply the numerator alone by 2. In this case, you multiply the denominator alone by 2. And you got the appropriate results. Multiplying the numerator alone by 2 has the effect of multiplying the whole fraction by 2. And by the same token, you multiply the denominator alone by 2. What you effectively doing is dividing the whole fraction by 2. What about if we multiply the numerator and the denominator by 2? So let us say we have now 48 by 2 over 12 by 2. Well, you could see that the 2's will cancel. But let me step aside from that for the time being and multiply it out. 48 by 2 is 96. 12 by 2 is 24. 96 divided by 24 is, guess how much? 4. So, if you multiply the numerator and the denominator, in this case, by 2, what you are in fact doing is nothing really, you know. You're not changing the value of the fraction. Remember, in a separate video, I would have discussed the whole issue of what I refer to as the unit fraction, I think it was. The unit fraction, no, the whole fraction. The whole fraction. Meaning, you have a fraction whose ultimate value is 1. Which is to say, if the numerator and the denominator are equal, what you have in fact is a whole fraction. What you have in effect is a whole fraction, which is to say a fraction whose value is 1. So in other words, multiplying the numerator and the denominator by 2 is the same thing as multiplying the original fraction by 1. Which means that the value of the fraction does not change. However, the appearance could change. And there may be instances where you may need to change the appearance of a fraction as a means to an end, as a step in carrying out some kind of working towards solving a question. So for example, you may have a situation where you're working out something with a denominator of 12. And for some reason, it may be in your interest to express this fraction 48 over 12 as another fraction with a denominator of 24. So you want to change from 48 over 12, you want to change from 48 over 12 to something over 24. For whatever reason, right? 12 by 2 is 24. So all you do is multiply the numerator by 2 as well. You get 96 over 24. 48 over 12 is the same thing as 96 over 24. Both of them are equal to 4. So it is important to understand that you could have two fractions that are different in appearance but identical in value. And you get that when you multiply the numerator and the denominator by the same thing, by the same constant. Right? Basically what you're doing is multiplying by 1. You're multiplying by the whole fraction. The appearance change, but the value remains the same. So, just to recap, right? Well, recap this example. We'll do another example in a bit. You multiply the numerator by 2, the whole fraction multiplied by 2. You multiply the denominator by 2, the whole fraction divide by 2. You multiply the numerator and the denominator by 2. The fraction remains the same. The value of the fraction remains the same. So, what about if we take fractions where you can't really see, like this one, I deliberately did it so you can see the 4 multiplied by 2 to get 8. You can see the 4 divided by 2 to get 2. And you can see the 4 remaining the same 4. So let me just understand that the same thing that we just demonstrated using numbers that we could see, feel, and understand, that same principle remains even in the case where the fractions are made up of numbers that we might be familiar with the numbers, but we mightn't be familiar with the fraction. Watch. Suppose we have, and I'm going to deliberately use some crazy looking numbers. Well, not crazy looking numbers, but the way I'm going to mix the numbers will be a little unfamiliar. But that's the whole point. That's the whole point. That is the whole point. Suppose we have the fraction. Suppose we have the fraction 7 over 11. Suppose I want to multiply this fraction by 3. 7 over 11 by 3 is simply 7 over 11 multiplied by 3 is simply 7 by 3. You multiply the numerator alone over 11, which would be 21 over 11. So in other words, 21 over 11 is 3 times 7 over 11. If I wanted to divide by 3, 7 over 11 divided by 3. Once we know the thing that we just spent some minutes discussing, we could bypass the whole step of reciprocating the 3 over 1 and multiplying by 1. So we could bypass that. And we could say simply that 7 over 11 divided by 3 is the same thing as 7 over 11. You multiply the denominator alone by 3. That is equal to 7 over 33. So 7 over 33 is 7 over 11 divided by 3. In other words, 7 over 33 is 1/3 of 7 over 11. Another way of saying that is to say that 7 over 11 is 3 times 7 over 33. And of course, the next one is that if we have 7 over 11 and we want to preserve the value while modifying the appearance, then we can multiply the numerator and the denominator by 3. So in other words, you're multiplying by the whole fraction, which is to say 7 by 3 over 11 by 3, which is equal to 7 by 3 is 21, 11 by 3 is 33, and that's it. So in other words, if you're trying to change the expression, if you took all the trouble to multiply 7 over 11 by 3 over 3 to move from here to here, then having arrived at 21 over 33, you're not now going to reduce it back to 7 over 11 by dividing the numerator and the denominator by 3. The whole point was to get here for whatever your purpose was, whatever your purpose may be. You modify the appearance without interfering with the value. Right? So we demonstrated the concept and the principle using a fraction whose ultimate value was an integer. So you were able to see the integer multiplying and you could see the integer dividing. What I want you to understand is that in cases like this, where you don't have the luxury of knowing that the fraction's ultimate value is an integer, the same thing applies. You multiply the numerator by 3. What you have just done here is multiply the entire fraction by 3. You multiply the denominator by 3. What you have just done is divide the entire fraction by 3. And of course, you multiply the numerator and the denominator by 3. You haven't changed the value. The only thing you change is the appearance. All right. So with that, we close off this series of videos on multiplication and division of fractions. Unless something else come up, which happens from time to time. Sometimes I would finish a series of videos and then I'll say, hey, I forget this, and then I'll do a short video and I'll put it in either at the end or somewhere in the middle, as you know, between a couple of the videos. So that is it. Multiplication and division of fractions. Stay tuned.